I welcome you all to the Spark Research YouTube channel. This is Dr. Virchandra, Assistant Professor in the Department of ECE, and this is another session for this particular course, Signal Processing. And in this session, we are going to take the questions from this GATE 2025, right? So that has been asked, which is particularly related to the Unit 3 and 4. Before going ahead, let me tell you, since this course signal processing belongs to the units, the second year course. So if you are preparing for GATE, like you can appear in the GATE 2028. So like whenever you are solving any questions from any subjects, you will be bit closer to the cracking the GATE. So always remember, every problem you solve today brings you one rank closer tomorrow. So don't ignore the questions from the gate. Please prepare for tomorrow. So let's see the questions. So this course is very important for the gate definitely, and the not only for the signal and system, but also if you are aware with the signal processing course, you can solve the questions related to the network theorem, your control system, and the communication system. All these, right? So here is the course for the network signal and system. So here you can check the paths, continuous time signal and discrete time signal. So these are the very important topics, right? Okay, let's take the question. So question is, let xn be a discrete time signal whose z transform is xz, right? So z transform is given of x of n. X of n means some discrete type of function, right? So here the z transform of your x of n is given. Now they are asking the discrete time Fourier transform, that is DIT FFT of xn always exists, right? So and then the ROC for xz contains neither pole or zero. So first question is related to the DTFT, second question is related to the ROC region of convergence, third is also related to the region of convergence, and fourth one is the one of the important results, right? So let's see the solutions. First of all, before going ahead, like let me tell you very clearly, this is the one of the unit circle. If you find the ROC for the Z transform of your the function, then you will get these type of the impulse response, these type of the the characteristics. So here you can see that the R is equal to 1, like here you can see, and Z is equal to 1. For this you can draw this circle. And so if the poles are inside this circle, means in the green area, means it is stable, outside means not stable, right? So and what is this Z transform? So Z transform is nothing, your x of n z to the power minus of n. So that will give you the Z transform. And similarly DTFT and Z transform both are same only, just replace Z is equal to e to the power minus j omega, you will get the DTFT. Okay, so let's see the solutions. So region of convergence, what is the actually the background of this question? So region of convergence is another important, like option B and C related to that. So that is the all the values of Z that makes the summation to exist form a region of convergence in the Z transform domain. So whatever the possible values of Z, so that is what and outside, of course, outside the region of the convergence, that another will cause the summation to divergence, right? So that reason we have to find. So here is the table. So here, like if you will see the table, x of n, of course this is your z transform of x of n, and del of n, what is the z transform of del of n? 1, right? So is this dependent on any pole? Is it have any pole? Pole means is there any divided by z minus 1, z minus 2, anything? Nothing is there. Means 1 divided by nothing is there, means it will always, like it will be stable. So region of convergence will be the entire plane just greater than 0. So the option C is talking one of the option is talking about this one only, right? So means this will be stable always. Similarly, you can check the ROC. Here is the ROC for the different functions you can check, right? So let's take the question now. This is the background. So first x of n always exists. So of course not. So DTFT, that is discrete time Fourier transform, will exist only if sequence is absolutely summable, right? Then only. Otherwise, if it is not summable, means if it is like the total integration will becomes like infinity, in that case it will not exist. Like as for example, xn is equal to 1. So this is not correct. So option 1 is not correct. Option second is ROC of xz, that contains neither pole or zero. So definitely it should not have pole. Pole means something divided by z minus 1. So here pole is at 1, right? Z is equal to 1. Something divided by numerator, but denominator means numerator is called your zero. In that case, like numerator may be 0, right? Means in that case pole may be exist. So this is not correct one. Third, DTFT exists if the ROC contains unit circle. That is also correct, because whenever we are talking about the unit circle, always it will lies in the ROC. So here is your unit circle, right? And x of n, this one already we have seen in the last slide. So x of n is del of n. So del of n means 1 into del of n, 2 into del, whatever. In that case, ROC will be the entire plane, means magnitude of your z always greater than equal to 0, right? So this is correct one. So no pole, because there is no pole at all, right? Because the the z xz will be here, how much? That is equal to alpha. So that is why it that it may not have any pole. So of course it will be stable. So option C and option D both are correct. Okay, so let's take the another question. So consider a continuous time finite energy signal f of t, and whose Fourier transform vanishes outside minus omega c to omega c. So band limited signal is given, that is frequency is your f of c, omega c, and the signal ft is uniformly sampled. Yt is equal to this, right? So this is concept related to the communication system. So here you can see how can we apply the signal, the signal system technique, right? So yt is nothing, that is ft and pt. Ft is your transfer function and pt is the input, right? So for the time being, let's talk about this input. Input is already given here. What is this input? Input is your pulse train, that is pt, already given here, that is del of t minus tau minus nts. So input is given. Now the sample signal y2 is passed through an ideal low pass filter, right? So low pass filter is given. This is so suppose here this is your omega, and here is your amplitude, right? So gain is there. So there this portion is passing, so that is why this is low pass filter. And if you convert the low pass filter, the time to frequency domain, frequency to time domain, this will give you the sync function. So this is what. So if you wanted to check it, you can check the window function also for triangular, for rectangular case, right? So the same technique we are using here also. So we have to calculate the output, right? So here f of t, as per your answer key, your answer B is correct, means the f of t minus tau must, like if tau s is less than pi by omega c. How is it? Let's see. So already given, that is Ts is less than pi by omega c, and output nothing, that will be your f of t minus tau and exactly the pulse train. So how exactly it will be? Suppose this is your f of t and you are sampling by the sample train, like so this will discretized only, right? So this will discretized your on the x-axis. Then further we are passing through a one rectangular type of window function, right? Right, having the frequency like low frequency, and then finally it will be the output. So here it is your y of t. So we have to find this much frequency of y of t. Okay, so y of t output will be y, the f of minus t. So in more detail, let's see. So the first of all f of t is given, and pt, that is pulse train, is given. So this is your pulse train, and here yt is equal to nothing, your f of t into p of t, right? So now if you will convert this y of t into the frequency domain, that is the multiply by exponential of minus e to the power minus j omega t, and here further you can rewrite like omega s will be equal to twice pi by ts here, right? Okay, so further in order to the reconstruct your message properly, this is the one sampling theorem. Actually omega s must be greater than twice of omega c. So omega s means twice pi by 2s must be greater than twice the twice pi of the 2 omega c. So ts must be less than pi by omega c. Further, this is a fundamental one, and since we are using the low pass filter having this sync function, so since we are using the low pass filter, so it will only pass the omega c, and twice of omega c, or the the minus of twice of all the higher frequency will be eliminated. So finally your output will have only f of omega e to the power minus j omega t, and so it will convert back into the time domain. So f of t minus tau it will be. So ts must be less than pi by omega c only, right? So this case is right. So that's all in this session. Lastly, I will conclude with this statement. So play today, stay healthy tomorrow, and whenever you are learning, that will be for lifetime. So both are important. Do some physical exercise for your healthy life and learn something for your good future. Okay. Thank you.